Good morning. Today we are going to continue exercise 8b, and this is the second day in the exercise 8b. This is the second video on exercise 8b. In the previous video we have done till question number 9. Now here we are going to start with question number 10. Actually this question number 10 is a very simple question, but because of the cube I have taken this question because students are not very much aware, or students do not remember the formula of a cube plus b cube. That is why the intention of teaching you this question is to remind you the formula of a cube plus b cube. If we just know the formula of a cube plus b cube, then this question is nothing. It's too simple. So let me introduce you first of all the formula. The formula I have written in red color, right? You will be able to mark it, and then you can have this formula also in your formula notebook. The formula is a cube plus b cube is equal to a plus b into a square minus ab plus b square. So we can apply this formula on left hand side, and then we can get the right hand side solution. Is it okay? So see how simple it is. LHS, in the first step, as usual, I am repeating sine cube theta plus cos cube theta, right? I am going to now apply the formula a cube plus b cube formula. So first is a plus b. Your a is sine theta and b is cos theta. Is it okay? So sine theta plus cos theta. I got it here as a plus b. Now I have to write the another factor, a square minus ab plus b square. Now when I am writing it, a square means sine theta square. So sine square theta. Sine square theta. Now this is a square minus ab plus b square. If we want, for our own benefit, for our own reason, we can change the order also. I would like to write this a square and b square together. There is a purpose, you will know it. And then a minus ab I will write at the end. Is it okay? So I am now going to write the b square. B square means the cos theta square. So that means it is cos square theta. And then after that I will write minus ab. Minus ab means minus sine theta into cos theta. Minus sine theta into cos theta. Is it okay? Now see, you got the answer. The first bracket is as it is, because sine theta plus cos theta, right? And in this another factor, sine square theta plus cos square theta, we have the trigonometric identity. We know what is the numerical value of this one. So we can just write the numerical value, which is 1, and then remaining as it is minus 1 minus sine theta into cos theta. So just in one step you got your result. Therefore, this question is done. Is it well understood? Next question is question number 12. Right? I'm going to start with question with left hand side, LHS. First, let me rewrite. This is 10a plus cot a whole square. This is my left hand side. This is my left hand side. Now, my left hand side is in terms of tan and cot, and right hand side we have is in terms of cosec and sec. Right? So, how can I solve this left hand side so that I can get this right hand side? So, let me begin this question. First of all, for me, I don't see any identity for cot 10a. I don't see any identity for cot a. Okay, so I am not in a position to use any of the trigonometrical identity. But what I can see is there is an overall square sign. So first of all, I am going to use the perfect square expansion. Expansion of perfect square. A plus b whole square. Right? Let us see whether we get some result or not. This is 10a square means 10 square a. Then let me write 10 b square. This is cot square b, cot square a, and then 2ab plus 2ab. So this is plus 2 10a into cot a. Is this okay? Now this 10 square a plus cot square a. We don't have any identity for this. We have identity, but then before we apply any identity, let me solve this part, because the product of 10a cot a is always equal to 1. The product of 10a cot a is always equal to 1. How it is 1? I will show you. After that we will deal with this one. So this is your tan square A plus cot square A plus, how is this becoming 1? I will show you. This is 2 as it is. This tan A I can write as sine A over cos A, right, into cot A I can write as cos A over sine A. This actually was not required, but I am writing only to show to you that how the product of tan A cot A is equal to 1. From next time, whenever you see the product of tan A cot A, you can always write this as equal to 1. Cos A cancel, sin A cancel, therefore this whole thing will become 1. Therefore 1 into 2 is 2. Is this very clear? So I am getting now tan square A plus cot square A plus 2. Is it okay? Tan square A cot square A is equal to plus 2. Is this very clear? Now, for tan square A, from here, from these two, we can easily get this result. Maybe by writing the identity. We can write the identity, we can get it. Is it okay? Because tan square A will be equal to sec square A minus 1. Tan square A, we can write as sec square A minus 1. This tan square A. And then cot square A we can write as cosec square A minus 1. Is this okay? And then at the end you can write this as 2. Clear? Now from here you see this minus 1, minus 1, minus 2 and minus 2 and plus 2 is cancelled. So you get your answer sec square A and plus cosec square A. This is your right hand side. Is it okay? Thank you. Now the next question is question number 14. Question number 14. If you see this question number 14, we have so lengthy left hand side and right hand side is just 1, right? Obviously we have to start this question from the left hand side. But when we look at all these trigonometrical ratios, we understand that there is no identity for any one of this term, right? Since we don't have any trigonometrical identity for any one of this term, therefore we can try to solve this question by changing them into basic trigonometrical ratio or fundamental trigonometrical ratio. Okay, so let us do this part. LHS, one step, just repeat cosec theta minus sin theta, sec theta minus cos theta, and then tan theta plus cot theta. First step, I am just rewriting the left hand side. Next step, now whichever part is possible, we will write in the fundamental trigonometrical ratio. So for cosec theta, we can write this as 1 over sin theta minus sin theta as it is, because it is already in the fundamental trigonometrical ratio. This is reciprocal of cos theta, so 1 over cos theta minus cos theta, right? This third bracket we can write as sin theta over cos theta plus cos theta over sin theta. Alright, now let us simplify each bracket. In this first bracket we have this first ratio as a fraction number, another is as a whole number. I can consider this as a fraction number, I can consider this also as a fraction number. For me it will become more easy taking the LCM. The LCM of these two will be sin theta. LCM of sin theta and 1 is sin theta. Cross multiplication 1 minus sin square theta. First bracket. Another bracket, similarly, LCM is cos theta. Cross multiplication 1. Cross multiplication minus cos square theta. Cos square theta. And then third bracket now. LCM of these two, cos theta into sin theta, right? Cross multiplication, because direct multiplication we have got the LCM. So sin theta into sin theta, sin square theta plus cos into theta, cos square theta, right? Now, this 1 minus sin square theta is equal to cos square theta, we can write down, we can write as sin theta. 1 minus cos square theta is equal to sin square theta. Write this as sin square theta over this is cos theta, right? Third one will become 1. This will become 1. Sin square theta plus cos square theta is equal to 1. Denominator is as it is, cos theta into sin theta. Is this okay? This sin theta multiply. So sin theta into sin theta, sin square theta. So these two will be cancelled with this one. And cos theta into cos theta, cos square theta will be cancelled with this one. So cos theta into cos theta will be cancelled with this one. Everything is cancelled. You are remaining with 1, and this is your right hand side. How simple question is this, right? This is the beauty of trigonometrical identity. Trigonometrical identity questions are really interesting questions, right? Thank you. Now we can see question number 15. Question number 15, once again, we have more complicated terms on right hand side. So we will start this question from right hand side. Okay. Let me start this question with the left hand side, LHS as usual. First of all, the left hand side term, cot A plus tan B divided by cot B plus tan A, right? But now when you look at this trigonometrical terms, you will realize that we don't have the identity for any one of these terms. And I told you, when you do not have the trigonometrical identity for the terms, what you can do is you can solve this question by changing them into fundamental trigonometrical ratio. So let me do that. So cos A over sin A we can write, plus we can write this as sin B over cos B. Come to the denominator now. This is cos B over sin B, right? Then tan A is sin A over cos A. All right. Now we can simplify the numerator. This whole part I am circling it for your convenience, right? You can simplify. You can consider this and then simplify, and then you can simplify this denominator also. So when you simplify this, what do you get? First of all, the upper one, the LCM of this will be sin A cos B. Is it okay? Sin A cos B. Is it okay? And now the numerator will be cos A cos B plus sin A sin B. Are you getting it? Now let us come to the denominator part. Let us come to the denominator. Okay. Similarly, sin B cos, sorry, I have to make some space. I will write small. Sin B LCM. Sin B cos A. Numerator now. Cos A cos A cos B. Cos A cos B. Cos A cos B. And now this way it will go sin A and sin B. Right. Now this line is seen this time immediately as a division sign, because above this or below this, if you have a fraction number, this will be always taken as the division sign. Now change this division into multiplication, so the denominator will go upside down. Let me rewrite. Is equal to cos A sin B. I will draw the line here. Cos A cos B, cos A cos A cos A cos B plus sine A sine B, sine A sine B divided by sine A cos B, sine A cos B. Is it okay? And then this will go upside down. So sine B cos A will go up. Sine B cos A will go up. The remaining will come down. Cos A cos B, cos A cos B plus sine A sine B, sine A sine B. Did you get it? Okay. Now what will happen is these two are same. So this will be cancelled. Am I clear? Now make the ratio with the singular angle. So we'll write here as cos A over sine A. We cannot have with a different angle into sine B over sine B over cos B. Is it okay? So this gives you what? Cot A, and this gives you tan B. Cot A into tan B. Cot A into tan B. Is this very clear? Where we went wrong? Question number 15. Oh, this was not sec A. This was not sec A. This was cot A. That's why I thought, how come? Cot. This is cot A. This way you get the result. Is it okay? Yes. Thank you. Now we are moving on to the last question for the day. Right? This is the last question we are going to do of exercise 8b. Now this is left hand side 1 plus cos A over 1 minus cos A is equal to cosec A plus cot A whole square. Now this time, in this question you can see that your right hand side is now more complicated. So we will start this question with right hand side. RHS is equal to cosec A plus cot A whole square. Now when I see this question right hand side and then my target is now to get this left hand side, I feel that this question should be more easy is because left hand side we have all in the fundamental trigonometrical ratios. Is this okay? So we can try to solve this question by changing them into fundamental trigonometrical ratio. Let us see whether we get it or not. So first will be, this is the reciprocal of sine A. So like this as 1 over sine A plus cot A we can write as cos A over sine A. Sine A. And this is whole square. Is this very clear? Now we can simplify. When you simplify, this comes as sine A. The LCM of these two will be as it is, sine plus 1A. Is it okay? And then the denominator will be 1 plus cos A as it is, because the denominators were same. So LCM, when you divide this by the denominator, you are getting 1. So that way 1 plus cos A will be your numerator. Is this alright? And then whole square. Now we can give this power separately to the numerator and to the denominator. Okay? This is 1 plus cos A. Because the numerator is going to be somehow like 1 plus cos A only. Therefore, I don't want to make much difference in the numerator. And then this I will give to the power 2. Denominator, I give this power to sine A. So this will become sine square A. Now, I'm getting little closer to the left hand side. So what more I will do so that I can get this left hand side is, now let me change this sine square A, right? Because we have the identity for this sine square A. This is equal to, numerator will be as it is, 1 plus cos A whole square, and this sine square A we can write it as 1 minus cos square A. Am I very clear? After writing the trigonometric identity for sine square A, I can see this denominator as a difference of a square. As the difference of square. 1 square minus cos square A. And therefore, I can write this in the factored form. Numerator will be as it is still. 1 plus cos A whole square. Denominator I will write as A minus B, that means 1 minus cos A, and into 1 plus cos A, 1 plus cos A. Is this okay? Now I can see there is some similarity in the numerator and the denominator. So that will be cancelled. This is completely cancelled. The power of this one will reduce by 1, and therefore you get your answer 1 plus cos A, 1 plus cos A divided by 1 minus cos A. Is this very clear? So with this you got your right hand side. With this we are ending the session. This is the end of your exercise 8B. After completing this question number 18, after this video, you will have your assignment from question number 10 till question number 19. From question number 10 till question number 19. Maximum questions I have already done. Maybe maximum you have 3 questions left over for you to practice and then learn. Is this very clear? So thank you so much. Have a nice day. But please do not go outside. Stay at home and take care of yourself and your family. Thank you so much.